Hi and welcome. In today's demo, we are going to demonstrate how aarna.ml GPU cloud management software integrates with the DDN external storage. This integration is really very seamless. Let's look at the demo flow. So we'll start first with importing the infrastructure, which will be comprising of the bare metal and the DDN external storage. Once the infrastructure is imported, then as part of step 2, we'll create a tenant user, and the tenant user as part of step 3 will allocate the bare metal, and it will also allocate some external storage to itself. That external storage will be mounted to the bare metal that has been allocated by the tenant, and this all happens transparently at the backend. aarna.ml GPU CMS integrates with the DDN and makes this as zero touch experience really for the end customer. And then we'll just go and validate the DDN configurations in the DDN admin portal as part of step number 4. And finally, at step number 5, we will log into the node, validate the access, create the file, and see that it is all proper. And then we'll also show you the deallocation flow of the storage and the bare metal. So let's move on to the demo then. We are at the login page. Let's log in as an NCP admin. After logging in, you will see the dashboard that is comprising of various statistics of total number of GPUs, the free GPUs, the total number of servers, the storage. Currently, we haven't imported any infrastructure, so you don't see anything here. Let's start with the importing infrastructure. Let's provide a CSV file for it. So you see that we have imported one server and one external storage, which is the DDN storage. So you can see the name of bare metal server that we have onboarded, which is CMS. You can see the IP address of it. As a next step, let's onboard a tenant. Create a tenant name Aarna and say add tenant. The tenant has been added successfully. Now let's allocate a bare metal for this tenant. So this is one of the existing bare metal in the catalog. Let's select that. Press next, provide the OS versions, the CUDA versions, etc., and say allocate. So the bare metal server is getting provisioned. This has successfully provisioned. Let's go ahead and allocate the storage. So we'll allocate the parallel file system. The DDN supports cluster file system, so that is what would get allocated. We select the DDN storage. We select the compute node, which is the CMS that you just saw some time before. Tenant user provides the size that he or she wants to get allocated, and just say allocate. So here in the backend, aarna.ml GPU CMS integrates with the DNN, provisions the tenant, allocates the storage, and also creates the north-south isolation for accessing the storage. So let's see the details. You can see that provisioning has happened. So in this, you can see the mount point, allocated storage, IP address of the storage server, which is an isolated north-south network. It will be different for different tenants. Now here we are going to show you DDN portal. You see the DDN portal dashboard where allocation percentage is shown. The object storage distribution across various nodes is shown on this page. Let's see various other details. The servers, you can see ESVM1 and ESVM2. So these are the DDN storage nodes. We are clicking the file system. So this is the testfs Luster file system, and you see bunch of various Luster file system objects. So you see the management targets, the management server, the metadata targets, the object storage targets where really the your data gets stored, and the OST pools. So these are the details of the Luster file system named testfs. So what is the space consumed, the space available, the status, which is the management server, number of metadata targets, number of OSTs, and also the mount point command. Let's now come back to the CMS portal. Now we will log into the bare metal named CMS that we had allocated to ourselves and validate that we are able to create a file on the external storage allocated. So we are just running the df command, and you can see mount point of the external storage. We are creating a file with touch command. You can see that it is successful. So that's how, in a very seamless way, the mount point got accessible to the tenant bare metal. Now we will just show you the deprovisioning flow. So we will first deallocate the storage, external storage, deallocate, and then finally we will just also deallocate the bare metal from tenant user. So this is all for today's demo. Thank you for watching.